I just don't.
Oh, no. Yeah. No, and that's, they're all different. They're all a little confusing. That's a different style fire pump, I remember this room being organized really well. But yeah, it's different in that there's no supply line. Just coming right in the pump. It's all flowing up out of there. And so, yeah, that's why that pressure gauge is 0. Because there's a check valve there and it's just pressurizing it up to the pump. Yeah, that makes sense now. So there's no pressure on that because it's pressurized by the jockey pump up to the check valve there.
That's what was in the garage. I don't know.
Yeah, I know it's underneath the ramp by feet over there, what it said. But it's gotta go in here.
The water plumbing is getting still checked.
You're talking about the water tower?
Yeah.
Basically on the other side of this wall.
Yeah, I remember being in here.
Yeah,
It was right
and they
there.
completely enclosed it, but they do have to inspect, test, and maintain it, just like they do at the big one that we can access over at the original Centene at the corner of Hanley by us. So they've got to be able to get in there. This should be their access to get in that tank, whether or not they drop a diver in there or whether or not they send a remote sub. It has to be inspected.
That's our business.
Well, I guess
Your business. Then you need to capital back. Those posts are earthquake rated? Why they're made like that? Earthquake rated? They're meant to
float a little bit, that's why they're mounted out now.
Yeah, that's based off code requirements too.
Well, yeah, what does that say? There's usually some good.
Well, okay, providing someone that are at 750 GPM.
Steve.
Five. 265 PSI. Your max.
Okay. Yeah, no, I mean, that's good.
Yeah, 750 GPM pump.
There you go. And it had 4 test header outlets, which, you're apparently supposed to add those up and be able to figure out the capacity of the pump, but this one, this 750 right here, and like you said, 265 PSI is the system demand pressure. So our next part of class, we're going to talk more about that of, how or when or why we would set up series pumping, to meet that pressure. I mean, we could create that pressure with our hydrant alone, but then we're giving up some capacity too. And there's been, examples where sprinkler's been better fed by, FTC supply with a series pumping operation rather than going off the building pump. Because the building pump is one speed. It shouldn't go up or down to meet any demands that are coming out of it. So it's one speed set, and that's what you get. You guys look around, and if you're done, we can go take a look at first floor standpipe outlet, see what that looks like, and just kind of be familiar with that, size it up from there.
So system demand pressure here, probably from the outside, just an educated guess, until somebody can relay that information.
Right, and in studying these things, the estimations are real close to what the system demand is, There could be some engineering stuff or problems or excess friction loss in the system or other demands on other floors, hazard floors or something that may make it a little bit higher, but most times the estimation of 5 or 6 per floor gets you real close to that system demand pressure.
But you need a 100 PSI hydrant to get this.
Okay, yeah,
Just
so
with no series pumping.
yeah, getting a little bit ahead. the NFPA says we should hook up one pumper for every 150 PSI of the system demand. So other departments have made a real simple chart of like, if it's a 1 through 10 story building, this is what you pump it at. If it's 1 through 6, 6 through 10, that way, there's no math. You look at it and you can set it up that way. And it's color coded to say, well, once you get above 10 floors, you're gonna use 2 pumpers. So what Brian was asking is, taking water from a hydrant, and that goes back to that first placard on an early slide we showed. Is one of the most important things when you're pumping is the relationship between residual pressure and discharge pressure. So at a draft, the pumps are rated for 1,500 gallons a minute while creating 150 PSI. That's a key number. So once you create more than that, then you lose capacity of your pump. And that's how these pumps work too. So if we have 50 coming in, let's say, let's do easy math. If this is 250 system demand, we have 50 coming in our truck, and we add 150, we're well within the capacity of our pump. So we should be able to exceed 1,500 gallons a minute, because that's at draft. So once we have 50 coming in, if we go up to the RPMs and add 150, that'll put us at 200 PSI, right? Well, once we create more pressure than that, we widen that gap, our pump starts to be able to lose capacity, and that might be what's happening in the ladder truck. But yeah, and it's the way our pumper works. At 150 we get 1,500 gallons a minute. At 200 we get 1,000, and at 250 we get 750 gallons a minute. So it's NFPA recommendations. It's worst case scenario, but if there's a lot of demand you need from this pump, so 3 lines with an 1.25 inch tip is close to 1,000 gallons a minute. So we're going to outwork this one. That'll be a really bad fire, and there'll probably have to be something going wrong in there. But if we had to do that, we'll set up a series pump. So that's what we're going over next. So we'll draw that out, go through it step by step. It'll be a little easier to understand. Good question. All right, so I think that's it. If you guys are all done, just take a look at the standpipe valve and then exit from here, all right?